Welcome to the Walton Pi. Today we're going to be talking about how we can find the volume of objects of rotation, and we are going to specifically be talking about the disk method. So in our last video, we showed how we can often find the volume of a three-dimensional object by taking cross-sections of the area and then integrating the area of those cross-sections to then find the area of the entire object. So if you remember, the formula we used was the volume is equal to the integral from a to b, so from the start of the object to the end of the object, of a of x, which represents the cross-sectional areas, multiplied by dx. So when we are dealing with an object of rotation, usually very nice formulas to be able to find the cross-sectional area a of x. So for example, if we are finding the volume enclosed by this function f of x after rotating about the x-axis, and we were slicing vertically, our cross-sections would be circles. And so since the area of a circle is always pi r squared, we can rewrite the volume formula into a more specific form that will always apply when we are dealing with volumes of rotation using the disk method. The volume is equal to the integral from a to b of a of x dx. Since a of x is just pi r squared, we are going to now have the integral from a to b of pi r squared dx. And r is a function of x, because r in this diagram, for example, changes with different x values. So let's go through an example together. Let's find the volume of the object formed by rotating the curve f of x equals the square root of 9 minus x squared about the x-axis. So here is the shape, and we are rotating it about that axis. And so we can figure out that the volume is the integral from a to b of pi r squared dx. The question now is, what is a, what is b, and what is r of x? So r is going to be our function of f of x, since we can see that in our diagram. And then we are going to start at -3 and go to 3, because those are the places where the function, the square root of 9 minus x squared, intersects the x-axis. 9 minus 3 squared is 0, and 9 minus -3 squared is also 0. And so that's why we are going to be able to write this as pi times the integral from -3 to 3 of f of x squared dx. Since f of x was 9 minus x squared, we replace f of x with the square root of 9 minus x squared. So this then becomes the integral from -3 to 3 of pi times 9 minus x squared dx. So 9 minus x squared, the integral of that is 9x minus x cubed over 3. And so we multiply that by pi and evaluate it from -3 to 3. And so we get pi times 27 minus 9 minus -27 plus 9. And this turns out to be 36 pi. So that tells us that the volume of this would be 36 pi. Now this is something that we could have also figured out if we were to recognize that the square root of 9 minus x squared, that's a semicircle. And if we rotate a semicircle about the axis, that's going to create a sphere. And the sphere had radius of 3, so the volume is 4/3 pi r cubed. R cubed was 27, divided by 3 is 9. 4 times pi times 9 gives us the 36 pi. And so this checks out with the idea of the volume of a sphere. Our next example is going to be finding the volume of the object formed by rotating the curve f of x equals the square root of x minus 2 about the line x equals -3, and then we are bounding this by the planes y equals 0 and y equals 4. Since we're rotating the curve about a vertical line, the variable in this case is going to be y, not x, since our slices would be horizontal slices, so we would be stacking them vertically or in the y direction. So, since we first need to write the radius as a function of y, we need to rewrite the curve as a function of y. So we have f of x is the square root of x minus 2. That means that if we were to say that y is the square root of x minus 2, squaring both sides would give us y squared equals x minus 2. So x is equal to y squared plus 2. So since our curve is x equals y squared plus 2, we might think that the radius is just going to be our function, y squared plus 2. But that's not going to be correct. Since we're rotating about the line x equals -3, that is not one of the standard axes, so that means we need to add 3 to find the radius. Or in other words, we need to subtract -3. So if you were to rotate it about the line x equals 2, you would subtract 2. Or the line x equals negative 10, you would subtract negative 10. That's the way that we can figure these out. So the volume is the integral from a to b of pi r of y squared dy. So it's going to be the pi times the integral from 0 to 4 of f of y minus negative 3 all squared, because f of y minus negative 3, that is our radius. And so this becomes pi times the integral from 0 to 4 of y squared plus 2 plus 3 all squared, which becomes this. Once we expand that out, it becomes pi times the integral from 0 to 4 of y to the 4th plus 10y squared plus 25 dy, and this is going to be 772/15 times pi, which is about 1627.764. That's going to be the volume of this rotation. I hope this video was helpful in understanding the disk method. Please check out my next video where I will go through more examples, and then we will jump into the washer method and the shell method also for finding the volumes of rotations. I hope it was helpful. If it was, please like and subscribe so that I can continue to make these videos, and have a great rest of your day and good luck with all of your math.